Binary. Okay, so here is first a quick example of how binary works. So I'm going to be translating binary and by Adam G into words. So first binary translates into this, and by Adam G translates into that. So first, as you can tell, each letter translates into an 8-digit word, 8-digit sequence, which is called a byte. We'll get into that later. Okay, so first, what is binary? Binary is a coding system consisting of ones and zeros. In binary, 1 stands for on and 0 stands for off. 1 and 0 are called bits. Binary is read in 8-bit lines of code called bytes. A byte can represent any of 256 different characters, and those can be numbers, letters, in basically, I'm pretty sure, every single language. Or maybe not every single language, but most languages. It can represent all of those just using ones and zeros. So, back to that. For example, A would equal this string, B would equal this string, and C would equal this string. You may notice a pattern between these bytes, which is that all 6 of these first digits are the same, but that is not the case for all binary letters. Now, for all binary letters, the first 3 digits are the same. So, for example, the first 3 digits in the alphabet are the same when translated into binary. Many sequences, such as the alphabet, have 3-digit start similarities for each character. This is because it makes binary much easier to understand. It's so if you memorize the first 3 digits, then you'll be able to tell what type of symbol the byte will be quickly. Now, here are 2 examples. In the number sequence 0 through 9, the first 3 digits are 0, 0, 1, and that's through all of the numbers. So once you see that 0, 0, 1, then you can immediately know that this is going to be a number. Same with the alphabet. This is the lowercase alphabet. The uppercase alphabet has a different code. For the lowercase, it is 0, 1, 1 for the start, so then you can immediately know that's going to be the lowercase alphabet. Next. Binary is also a simplified version of all modern computers today, and is the simplest form of all positional number systems. A positional number system is a system that represents symbols using numbers. The oldest form of binary recorded was in the 9th century, where Xiao Yong, a Chinese philosopher, made a binary system called I Ching, based on the yin-yang. He represented the yin as 0 and the yang as 1 because yin was usually associated with negative and yang was usually represented with positive. Here are some examples of what I Ching would look like. So for all zeros, it would just be all yin lines because yin was associated with negative. But then on this one, where there is one digit, there is a yang on the front, and you can tell that because there's a little split between the 2 yins. So these are all place values too. So on the second one, you can see that that is 10. That is because the first line is 1s, second one is 10s, third one is hundreds, and so on. So that is another way that you can use binary. Okay, get ready to pause the video because this part goes really fast. Binary was created by Gottfried Leibniz in 1679 because he believed it was the Christian idea of creation from nothing. Gottfried made his invention of binary public in 1701, 20 years after he created it. Gottfried was a German philosopher and mathematician, and the co-inventor of calculus. Leibniz died in 1716 in Hanover, yet no one attended his funeral because he was out of favor. His grave was unmarked for over 50 years, and he was eventually eulogized by the Berlin Academy of Science because they had to admit that he worked there. Leibniz didn't have much close family because he was never married. His closest family member was his sister's stepson, who he gave all of his money to. And here are sources. Okay.